It was a ratio then, right? The ratio of the sides of a right triangle. Well, today it's going to be totally something different, but it's still a tangent, okay? So a tangent, and again, this is probably something on your vocabulary sheet, so don't forget about that. A line that intersects a circle at exactly one point. Now this is where, again, Mr. Troll is going to be trying to be wise and say, well, I think it hits here, here, and here, because obviously my pencil is a little thicker than one little point. Okay? So you can't go Kroll on us. All right? So what we're saying here is try to draw a circle. And obviously when I draw this line across here, does it hit exactly one spot on that circle? Probably not, because of the way my marker is, the thickness of my marker. But realistically, that's what we're talking about. Okay? So, see, I found this cool little thing here. Right there about that. So there's my point. Right? So my one point, this is going to be called the point of tangency. So when they talk about that in the book, as you're reading the section tonight, that you understand what that could be. So when we talk about common tangents then, we're just talking about tangents so tangents in two or more circles. And these could be a ray, it could be a line, it could be a segment. Does everybody understand what we're saying by those three terms? And the difference between a ray and a line? Everybody good with that? Okay. So the first thing that they're going to try to do is they're going to say, if I had multiple circles, how many lines of tangency could I draw? Okay, so don't look up here, Gabriel. This is actually kind of interesting. Okay, so here's the first example. Could I, now remember what the definition is. That it only touches one time. Oh. So can I draw a line, a ray, or a segment that touches those exactly one time?
Yeah. Yeah. Oh, yes. Yes.
Impossible.
What'd you say, Drake?
I don't think so.
Why?
Doesn't look possible.
Why do you say yes, Cam?
Because you can use a ray and just have a point instead of no one, like a apple.
You can't do that.
Right. So remember, it's got to only touch it at exactly one point. So if you go through the middle, you're touching all the things that are inside the middle.
Oh, that's stupid.
I know, that's
You
stupid.
can't do that.
So what is it, Drake?
Not possible.
Not possible, this one, right?
That one's stupid.
Okay? No. No. Because that, now it doesn't touch both of them,
Cool.
right?
That's such a
Has to touch both of them. Say what? All right, don't look again. Don't look again. All right, can I do it with this one?
Yeah, you don't mind, Brett.
Across the tops of them? Okay. So would you agree that I could draw this one right up here?
Yeah.
Any others? The other side, right?
This is a stupid one.
Any others?
Cutting it pretty close there.
This is stupid.
There's another one that's not another one.
No.
I don't know.
I'm gonna
No,
say
that's
no.
it.
You just stop looking at it.
Well, I'm trying to make you think a little bit.
Well, just tell us.
No. All right, turn away. This is a good one right here. Gabe, don't cheat.
He's
Remember.
not. I'm looking at Gabe's eyes. So.
All right.
Oh,
What is us?
So how many tangents can I draw between those two circles? That it only touches each circle one time.
a lot.
4.
A lot.
Four is it?
It's not infinite.
Dude,
It's
is
not,
infinity an option?
dude, it's not infinite, but there's a lot.
How many?
4.
Everybody agree with 4? So where are you going to draw them?
Segment right there. In the middle, right there.
So we're going to crisscross across the middle and then go across the top and across the bottom?
Wait, why can't you?
Why can't you just
Why can't you just put a segment
Yeah, that's
between
what I'm saying. Can you just
the point on the dot on the circle?
like
Like this, like straight across horizontally, like an x-axis.
Hang on. I understand what you're saying, so maybe I gave you a bad definition. Let's go back to the definition.
Not to the segment.
Line rear segment.
This says segment.
Oh, I think because, okay, so common tangents can be between those two, but a line, this specifically says a line that intersects a circle at exactly one point. So when we're talking about tangents exactly between, or just drawing a tangent,
So,
it has to be a line.
okay, so
Okay.
that only applies to common.
Right. Common tangents then could be a line, array, or a segment in the same plane. All right. So it's kind of a weird definition. I agree,
Yeah.
and that's the confusion. All right. So he said, well, why can't I just draw a segment straight across the middle of the two circles, and then just have a segment and a segment, my endpoints being on the circle. Okay. So it leads us to a couple theorems. So we're up to 10-10 already, in a plane. So, we need to start out with in a plane. A line is tangent to a circle. If and only if, so we're going to use that IFF again. It is perpendicular. What's that mean? Forms a 90-degree angle to a radius. Drawn to the point of currency. Not concurrency. Tangents. Okay, so draw a circle. Draw a tangent across the top. What's a radius again? So try to find your center. And then it says that it has to be perpendicular to the radius drawn. So where's my point of tangency? Wherever we cross, or wherever that one spot is. So again, yes, Riley's going to make an argument. Well, it's touching right here, 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 right here. But realistically, it's a thin piece of paper or a thin pencil or whatever, so it's only touching once. So this one's saying, when I draw that radius, this is perpendicular. That's what that definition says, or theory. Okay. So basically, if I'm talking about the distance from the center to the point of tangency, this would be the shortest distance. This right here, my radius, would be the shortest distance that I could come up with to the center. Go ahead, sir.
So if you draw like a right triangle or something, that's still.
Basically, you're going to end up having right triangles in this, yes. We're going to show you how to do that in a second. Okay, to the center. All right? So then we talk about tangent segments. And what do we mean by a segment again? So this is kind of what Cam was trying to come up with the other part. So a tangent segment is simply just segments that form tangents, but they start from the same common endpoint. So think about this. Basically, you're going to have a circle here, and then put a dot somewhere. So basically what this is saying is, if I start this right here and then I draw a tangent back where it only hits that one time, and mine's probably bad, I think I felt a big jut in it. And then we have it down over here. That's what it's saying. Any place that I put this dot, I can put it down here and I can get the same kind of ice cream cone look, right? Okay? So this theorem says this. These would both be tangent segments now. This and that are tangent segments. It still only touches the circle one time. Okay? And it comes from some random point, so it leads us to theorem 1011. If two segments from some point, but it has to be from the exterior. Exterior just meaning what? It's on the outside of it, okay? It doesn't matter where they are. If two segments from the same exterior point are tangent to a circle, what do you think is true about those two segments? What?
Congruent.
There you go. The segments are congruent. They're equal to each other. So you're going to have to be able to do some algebra to this. Because algebra is fun, right? Algebra? No. They're doing factoring right now. It's like the greatest part of algebra ever. Next part, then we talk. Everybody okay with that? So basically, as long as you can prove that this is a point and it only touches at one spot, so these are both tangents, this is congruent to that. Every single time. And then the last thing we're going to talk about are circumscribed. We talked about circumscribed before, right? Circumscribed polygons are polygons that what happens? Alright, is the shape on the inside or the outside? Remember we had our two words?
No, outside.
The first word we had was what? Inscribed, so the polygon was drawn on the inside. Circumscribed said it was drawn on the outside. So, draw a circle. And then try to so what happens? Every single one of them is what? Okay? Each side of the polygon, and it doesn't really matter what you draw. You could draw whatever you want. You could even draw a five-sided octagon or a five-sided stop sign.
Yeah,
Right?
they exist.
They exist. In Planet Gabriel. Each side of the polygon is a what? Is a tangent. And this is actually kind of a cool deal here. You'll see in one of the examples. Again, I think it's cool, but you guys might not.
Really cool.
So we talked about tangents, and that's what we're talking about. Okay? So my point of tangency is that one exact point, a line that intersects exactly that one point. Okay? So I believe that's where your question came about. It must have said what tangents instead of congruent tangents. Congruent tangents can be segments, but regular tangents would just be a line. But you're exactly right. That was a good thought process. All right, are we ready? Any questions with the words? We already did that one, right? Want to do another one? How many can I do this one? We already did this one basically, right? Where our circles are just... So how many can I do?
Three.
Why do you say three?
Because you can do one down the middle.
Yeah.
Can I do it one down the middle?
Yes.
If you
What
know
do you think?
they're at a certain...
Right here?
Yeah.
Let's see if they say so. Three.
Let's go.
Boom.
Let's go.
So again, this would be a major argument for Riley, right? He'd say, well, it looks like they smashed together. Again, we're not smashing the circles together when we hit them. We're bringing them as close as we possibly can, and as soon as they touch, boom, that's my 1 point. And then I can draw that line down. So that's pretty good rotation.
So what are we learning in this lesson?
We're learning what a tangent is. It's that line that only touches at one time.
We're learning something we'll never use again.
Yes, you will. In the homework.
I'm gonna use this.
All right, here we go. This is the one right here that's a little confusing to me. Okay? This one's confusing because of where 29 is. Now, if 29 is written where it is right now, is 29 representing the radius or the entire hypotenuse? It's got to be the entire hypotenuse because the radius is what? 20, right? Okay, so basically, they're asking you to prove theorem 1010 in this one. How do I prove if the radius is perpendicular to LM? I'm going to do Pythagorean theorem, right? Because if they are perpendicular, then that would mean that they form a 90-degree angle. So, is 20 squared plus 21 squared equal to 29 squared?
Is it here real for you?
Yes.
It is. So, is LM a tangent?
Yes.
Yes, and the reason why, if you had to justify, would be theorem 1010. That make sense? Okay. Kind of an interesting problem. So,
Favorite lesson. Yeah.
this is a good one right here because you got to do some math on it. So what the heck do I do in this one? I'm going to do the exact same thing basically, but now I have to do a little bit more math. So when I'm doing this one, I'm going to do what? X squared plus.
X,
What is my hypotenuse?
X plus 16.
So that has to go over here, x plus 16, and what do I have to do to that? I have to square the entire thing. So I have to put parentheses around this and square it. You cannot just take x squared and 16 squared and then put them together. Okay? Because the whole thing is x plus 16. And then 24 will come back here. Now a lot of people look at this and they kind of freak out because we're going to get x squared. And whenever you usually have x squared in a problem, you might have to go back in back. Okay? But this one's not that bad because what's going to happen to my x squareds? Well, watch. What's 24 squared?
576.
576. What do I do to the right-hand side of this problem?
Foil.
Foil, right? Will you turn that back,
Yeah.
please? So, remember, this is really that, right? When I say x plus 6 quantity squared, it's really using both of those parentheses. So now I'm going to do FOIL like Cam said. What's FOIL? So, what's my first terms? Outside, inside. Remember, outside and inside terms should always be like terms. So I should add them together. 16x plus 16x, right? And then what's 16 squared?
256.
So notice why you didn't have to freak out here. Because when I have an x squared on the left and an x squared on the right, when I bring them together, what happens? They're going to cancel each other out. So I'm going to solve for x. I'm going to subtract 256 from both sides. What do I get over here? 320 is equal to 32x, so what's x? 10. Now, what's the question? And does it make sense that x is the same in both cases? Because realistically, x is what in both cases? A radius. Exactly right. Exactly right. Okay? So, pretty cool problem, right? And again, every once in a while you might have to actually factor it. So don't freak out when you have to factor. Factoring is not that bad. It's really not that bad. So, here we go. The next one, AC and BC are tangent. So again, they should tell you all those. And as soon as they tell you that then you're looking at 10, 11. So C is my random point out in the middle of nowhere. And then I have two segments from the same exterior point that are tangent. So the segments are congruent. So again, make sure you answer the question. It says find the value of x. I'm just finding the value of x in this case, but if it would have then said find CA, make sure you answer that question too. And again, don't round until the very end. But essentially, all I got to do in this one is what? Set them equal to each other and solve for x. So what's x?
5.
X is 5. And again, they don't tell you, but then if they would, you would carry it on. Pretty simple, right? Same. This one's the cool one. Now, a lot of people look at this. Don't say anything out loud. Please let everybody have a chance to think about this. The round cookies are marketed in a triangular package to pique the consumer's interest. Aren't you piqued right now?
No.
Yes.
Don't you want to see what that cookie looks like on
Good
the inside?
marketing skills.
But then you're actually disappointed because why? It's not a triangle, so you actually lost a lot of cookie. Right? Gabriel will be mad when he opens up the box and sees that we lost all the sides. So, if triangle QRS is circumscribed about circle T, can I find the perimeter of QRS? So again, what's QRS? QRS is my triangle. Can I find the perimeter of my triangle? So here's the key. One, you got to figure out where things are. So what does 2 actually represent? 2 actually represents the little side, right? So 2 is actually right there, but it should also be right there, right? So if those 2 sides are 2, what's this side right here? Everybody okay? So if this is 6, what about MR?
6.
Why? Because realistically, we're right back to this right here, right? Where did we get 6? If the little part up here is 2 and the whole thing is 8, then I subtract those 2. Okay? So now if this is 6, this is 6 because we are tangents, they're both tangents, and they start from a common exterior point. So then if this is 10, this has to be 10. So what's my grand total?
16.
How much?
I was just saying all the sides. So it'd be
Yeah.
26, 36. So 12.
Just do the math. Don't guess.
36.
36. 36 what?
Centimeters.
Don't forget, because of some kind of distance, you need some kind of label. And perimeter is just whatever label you are, because all you're really doing is adding up all the numbers. Correct? So kind of a cool thing. You probably wouldn't think about doing those kind of things, especially before this section. But it is made possible because of those being tangents. I don't believe there's any more.
Give the outro.
Yeah, they're all.
See you next time, guys.
All right.